Hello, it's Dr. Bhatt here. Dear friends, students, and viewers, after having sufficient idea about precision and accuracy, significant figures, rounding up of significant figures, and practice on rounding on significant figures, now we move to use or apply significant figures in calculations. Calculations, mathematical calculation, or it may be a calculation in physics or chemistry formulas. Now, here is a hint provided here. Before we go into details, I'll just brief it out and provide various examples relating to calculations of significant figures. Here is a hint provided. For addition and subtraction, you have to look to the least number or the fewest number of decimal places. And multiplication and division, we have to consider significant figures with minimum number of significant, a number having minimum number of significant digits. And so this is the principle of addition, subtraction, multiplication, and division. Whatever may be calculation, we know that it comprises of addition, subtraction, multiplication, and division. So, what are amongst the number being worked out? We look into these principle, fewest number of decimal places, sometimes called as digits of precision. These decimal places are also regarded as digits of precision, DOP. And of course, the significant figures are significant digits in a number. We can know, we have already learned about it. So let us proceed how to find it out. Calculations involving addition, subtraction, multiplication are deciding the number of significant figures while putting up the answer. Now here, this is important. Determining or deciding the number of significant figures while putting up the answers. Sometimes we need to round up, maintaining the precision of the number or the answer uh, which you are putting up. So we shall go to different examples and consider the principles for such calculations. Of course, the result has to be reported in terms of precision and accuracy. To maintain the maximum precision, these are the rules. The result or answer of the addition or subtraction should be given with minimum number of decimal places. Of course, this is also termed as digits of precision or DOP. So it's here, and let us have an example about it. Here is an example. I have worked it out just as an example or illustration. A simple addition is here, and of course, you can call it as MCQ, and you have to find out the correct answer. Correct answer here. So, if you look here, in the first number, there are three decimal places. Number of decimal places, fewest, minimum is 3 here. While in the second number, the DOP or the number of decimal places are 4. So looking into this, perform the normal addition and revise it, put it up to have the minimum number of decimal places or digits of precision. So total is, in this case, total is 731.0181. Now we have to put 3 decimal places here, and therefore the answer is 731.018. Of course, rounding up is not necessary in this case, but in certain cases, rounding may be necessary. We shall go into it. Now, a note on rounding up. Here is the case. Suppose you are adding 513.768 plus 83.0231. It gives the value as 596.7911. So, here, how many digits are there in the decimal place? 3 digits. Minimum 3 here and 4 here. So, you have to retain 3 digits over here. 596.791 is the answer without rounding up. But maintaining the degree of precision at the extent of precision, if our results work with 597, because when you round it 596.791 using the principles of rounding or the rules of rounding, we find it is 597. It can be rounded up. Well, this depends upon our experimental methods and the reporting as desired. You can say it is 5.97 into 10 to the power 2. Now there is another case where I have just given you some type of experiment here. Go through it, and this is again a revision, an addition. So we know that there should be an alignment of the decimal places, decimal points, and the number. So aligning the decimal point, you have to add, in this case, 80.36 grams with 3.5 grams. So if you add it up, you get 83.86. Now, this can be rounded up. As in step 1, there is one decimal place, and therefore the answer can be written as 83.9. Now, I will ask you to go through this simple experiment, and which involves, of course you can go through it, which involves subtraction. Same principle as you have used here. Align the decimal places, perform the normal subtraction, and get the result. And if you have worked it out, I suppose you must have done it by now, and the answer you should get is 12.06 grams. That's there. Well, thank you for getting the correct answer. Then there is another explanation. Explanation are some just hints provided here, whatever I have given here. Multiplication and division. Till now we have worked on addition and subtraction. Now we work on multiplication and division. The result, now here, what we do, as I have already pointed out, we just take care of the number of significant figures. The minimum number of significant figure in a number, or significant digits we call it, with fewest significant figures. For example, of course, a simple example is here. 2.34 multiplied by 12.5. In each case, you find there are 3 significant digits. Therefore, the answer should have the same number of significant digits, 29.2. Similarly, in subtraction, also the same principle is followed. These rules ensure that you maintain appropriate level of precision based on precision of the original number. Why do we carry out and care for the number of significant figures? It simply indicates the level of precision. We want our report to maintain the maximum level of precision. Rounding, of course, can be done, as I've already told you, if the precision indicated is matched by the significant figures. So, next, another example is there where we are required to find out, go through it, you are required to find out the ratio of ratio of water to iron. Water is mixed with iron in a container or graduated cylinder, and you have to find out the ratio. Now, wherever we need a ratio, it simply represents a division. Divide it as usual, and you get 5.4387. But look here, there are three significant figures here in 2.53, and here there are four significant figures. So you have to adhere to three significant figures, and the answer should be 5.44. That's there. So we had sufficient example about significant figures, addition, multiplication, degree of precision, decimal places, and normal addition and subtraction, etc. Well known to us. Now there can be another case which is known as simplification. We may use an expression which calls for simplification. It may, the expression be may include parenthesis, square brackets, small brackets, and uh, medium brackets, exponents, multiplication, division, addition, and subtraction. So, well, this is the process order we follow for simplifying an expression, mathematical expression. And here again, the same principle is followed. Lowest number of decimal places of addition, subtraction, and fewest number of significant while performing multiplication and division. Since this involves simplification, this involves principles of uh, significant figures or decimal places or DOP, etc. Therefore, sometimes we call it as mixed operation. Mixed operation. Not a simplification, better call it as mixed operation, because we are caring for the precision of the answer you are getting of the report. Now, here is an example again based on multiplication and simplification, etc. You find that in the first case, please go through it. It is self-explanatory, stepwise. If you follow here, the answer is 3.7 into 10 to the power 4. And of course, the product is given here 10 to the power 15 and 10 to the power, that simplification. These exponents are divided, taking it out as common. So that way we get here 3.7 into 10 to the power 4. And the answer has to be retained with two significant figures here. And 2.0, two significant figures. And here 6.4, again two significant figures. So that is how the answer is of the question 1 and 2 is determined or given. And there is a simple division, question 3. If you go through it, again you have to maintain how many significant figures? 1, 2, 3 here. So the answer is 1.05 into 10 to the power 24. So these exponents are uh, determined separately. They are calculated separately like this. So it's well known to us. And then now I will give you a number of questions here. And the answers are provided here in the same way. Question 4, 5, 6, 7, 8. Please go through it. And it has already been explained. Look here, 386 added with 31. So here, 6 significant figures, here 5 significant, and you have retained 5 significant figures, and the answer is 9.61 something. So decimal places in 31. Look here, that's important. 31 without decimal place, no decimal place. Therefore, that two significant figures have to be maintained, and you get it 9.6. 16048 is not necessary. And just put 9.6. Similarly, here also it is 12, and that way it is 15 here, and it is 44 and 20. Well, then we take up further simplifications. Question 9, 10. Here, this is something relating to Avogadro's number. Some calculation has been made, and Avogadro's number, as we know, is 6.02214 into 10 to the power 24. So some calculation is related to this, and we solve it mathematically using simplification method, and the final answer has to be retained with significant digits. It is 5.8983 into 10 to the power 23, means 5 significant digits. 1, 2, 3, 4, 5. 5 significant digits here. Here again 6. Here there are 6 significant figures, and here you find 7 significant figures. So this will not work. The minimum significant digits here 4.6098, and that is retained here with the answer. Similarly, there is a simple question relating to density, determination of density, and here we put up the answer in terms of 7.81 gram per cubic centimeter. Density, mass upon volume. So weight of the water displaced is there. So that is a simple experiment. Now we take up a practice. Please answer quickly, and if there be any need, I expect you to please explain also. 609, I give you some time. Please go through and select the correct answer. These are questions of the MCQ type, multiple choice. Please go through it and get the answer. Okay, it's not a lengthy question. You can get it fastly or quickly. So, answer to the first question is 693. You can simply add it up and find out that 693.4. But the correct answer which you should give is 693. Why? Why not a decimal place? Because here we find that there is no decimal place in 600. Zero zeros, these are trailing zeros, only one significant digit is there. So this has to be maintained without decimal places. So 693. Similarly, next question, very simple, you can add it up. It is 98.5. Next question, 0.03. Number of significant digits here is 4 only. 4. One significant digit. So we have to maintain that significant digit. The 0 is not at all significant. This is just a placeholder of the digit 3. So one significant digit has to be maintained here. And again, here are certain questions. I suppose you must have solved it. The answer is given here, and also explanation. How many significant figures are retained? Like that, please go through it, and you will feel it convenient. If you answer these questions, you will definitely feel confidence in answering another question also, similar related question. Here the answer is 9,000. Again, one significant figure. So that's there. Then some more questions here. Because these are objective type questions. I'll provide you the answer a little later. Please go through it fast and get the answer. Okay, we proceed to question 6, 7, and other questions. I suppose you must have solved it. Please be quick. Yes, here are 10 questions. This is, of course, question number 10. And go through it, solve it yourself. And definitely, I'm confident that you must have solved correctly and write the correct answer amongst the four options given over here. Okay, we stop here. Thank you. And let us see what are the answers of the questions you have done or you have attempted. Here it is. All the answers are given over here. So please build up confidence going through the illustrations or examples here and following the rules about significant figures during calculations or reporting the results. Mind it, precision has to be maintained. Okay, thank you. Keep watching.